Welcome. Let's try to solve another Leetcode problem. Leetcode 76, minimum window substring. So we are giving a string S and we are giving another string T. We are not sure if S is longer or T is longer because sometimes S is longer and sometimes S is shorter. So we need to be careful about that. And we need to return the minimum window substring of S such that every character in T, including duplicates, is included in the window. If there's no such substring, we're gonna return an empty string. Let's just first use this example for ABC. So for this string, BANC. So for BANC, it has the character ABC, and so for A, at least it have one time, B at least one time, and C at least one time. So this one, the length is 4, so we're gonna return this string because this is gonna be the minimum, and we cannot find something like BAC because there's no BAC. Otherwise, it's gonna be BAC because the length is 3. And for this example, S and T equal, we're gonna return A. And for this one, S is shorter and T is longer, so there's nothing. So we're gonna return an empty string. So I'm gonna use two methods to explain it. The first method I'm gonna use the time complexity will be O m plus n times 52 because there are 52 characters because it both have uppercase and lowercase characters, and 26 plus 26 is gonna be 52. Another method I gonna just use O m plus n. I will optimize this 52. I think it is so the 52 or it can be 100. It's still a big number. So if I can optimize it, I had better optimize it. So I'm gonna use the sliding window to solve the problem. I'm gonna define two counters. So the counter for S is gonna be an empty counter, and the counter for T it is just a counter of T. So for the first method, I'm gonna basically use the brute force of sliding window. Because basically I needed to use a comparison of the two counters. So I'm gonna prepare a result and L. L is the left pointer. It's gonna be starting from 0, and this result would be S plus a hash. And the L would be 0. Why S plus hash? Because this string can be shorter. If I plus a hash, I can check that because I always check the minimum. If I do not plus a hash, so this minimum can become this character A. But this is not the possible answer because S would always because S should at least have 2 A's. But while I'm calculating the minimum, the result would always be the minimum. It's gonna be an A. But if I plus a hash, so after all, if there's no result, so the result would still be the S plus the hash. So if I get a S plus hash after all conditions of checking, I'm gonna return an empty string. So this is just a boundary check. So you will find it later. Now I'm gonna start. So for RC in enumerate S, so I'm gonna prepare the counter. So for DC would plus equal to 1, and then I'm gonna use the while to check. So while D more than DT. It means it must have a possible answer. So my result would be the because I'm calculating the minimum, so it's gonna be the minimum of result with S L plus L to R plus 1. Because this is gonna be the window. But currently I need to get a string, so I need to have a K would be equal to the length. So this just means for the minimum length, I'm calculating the minimum length. So which is minimum? Is it the length of the result or is it the length of SL to R plus 1? Then I'm gonna get the string. So this minimum actually is just for calculating the minimum of the string, but I need to have a lambda function for this K would be the length. I'm comparing the length. Which one gonna be smaller? I'm gonna return which result. Now I'm gonna update the SL. So the SL should be minus 1 and L should plus equal to 1. Now I can return the result. So if result not equal to my setting, so s plus the half. Otherwise, if it is equal, it means it is not possible. I'm gonna return an empty string. Yeah, as you can see, it is not so long, just a few lines of code. Maybe, yeah, it's just 8 lines of code. Let's just run it to check. Let me submit it to prove this also works, but it's gonna be really slow. That is because the time complexity is O m plus n, because as you can see, this is m, this is n, O m plus n times 52, because there is a dictionary counter. There's a counter comparison, and it is dependent on how many characters inside of the counter. So there are maximum 52 characters. So this is why it is so slow. Now we are gonna optimize this line. Basically, we're gonna make it O m plus n, because according to the question, could we find an algorithm that runs in O m plus n time? Because this gonna be a little bit harder than this kind of a solution. Yeah. But how can we check that? Yeah. So basically, for the characters, so for example, we are calculating the counter t. So for the counter t, for example, we have a character like ABC. Yeah. So for this example, we have ABC. So how many numbers do we need for each A, B, or C? It is 1, 1, 1. So we're gonna call this one as a need. It means there are 3 characters, so we're gonna use 3. It is dependent on how many characters. So yeah, so we're gonna need 3 characters to meet the condition. So we're gonna define a variable need, and then we're gonna define a variable have. We're gonna check how many A, B, C do we have. Yeah, if we can meet the conditions of our have variable. So for A, it is 1, it means the have becomes 1. If B also equals to 1, it means the have becomes 2. If C also equals to 1, it means the have equals to 3. So if this have equals to the need, it means we find a solution. Yeah, maybe this B already becomes 2, we still find a solution. And then we're gonna still use the sliding window to shift the L pointer to maybe reduce a B, it is 1. Yeah, we still meet the condition. We're gonna check. Maybe it is a sorter. Yeah, if this B becomes 0, we didn't meet the condition. And then we're gonna, yeah, still we need to fix the left pointer and go through the right pointer to check. And then we fix the right pointer and the left pointer becomes smaller to check. Yeah, yeah. So the idea is the same. We just need to have 2 more variables, need and have, and then we can solve the problem. Yeah. Now let's just define 2 more variables to optimize it. So we're gonna have a have and need. So the have gonna be 0 from the beginning, and the need gonna be the length of the dt, the counter of t. Yeah. Now from here we don't need the while check. We just need to use the while to check if the have equals to the need. Yeah. But before that, if this be C, yeah, so but before that, if this be sick, the counter of this character plus 1 yeah, let me check how can we make the have plus 1. Yeah, we need a check. So if this dc yeah, let's just use equal. If this dc equal to the dt with this character, it means we find a have. So the have would plus equal to 1. Yeah, because for example, if it is a character a, this one equal to that one, it means our have should plus 1. We find a character that meets the conditions. Yeah. Now we're gonna check this while this have equal to the need. Still, we're gonna have a result. It's gonna be the minimum, and here gonna still be the same. But we should try to find a method to reduce the have, because the have may become smaller. Yeah. But how can we check that? We have to check this character. So our current character is SL. Yeah. So if yeah, because the character at the left side is SL. Yeah. So if this character is inside a counter of dt, and this character DSL is less than the dt of SL. Yeah, so this means currently for this character the counter is smaller. It didn't meet the condition. So what are we gonna do? So the have would -1. Yeah, we didn't increase so much code. We just add a few lines of code. Maybe currently there's more lines of code. We just added 5 more lines of code, but the time complexity already becomes O(n plus n), because here we didn't use the counter. We just use the 2 variables, another 2 variables, have and need. Have means how many conditions, how many characters did we meet for this counter D, and need is how many characters in this counter T. Yeah. So if it meets the conditions, we're gonna start the while loop, and if the counter for this character is smaller than the counter of T, so we're gonna the have gonna -1. Yeah, if the have -1, it means we're gonna break the while loop, and we're gonna start to check the right side of the index. Yeah, we're gonna check the right pointer. It's gonna be shifted to the right. Yeah. Now let me run it to check. So the string index out of range. Yeah, let me check what is wrong with it. So if I need to check it from here because I cannot check the SL. First of all, this SL should -1, and after -1, this DSL I have to check. It may because from beginning I didn't use the counter of DSL -1. I have to -1 first. And then it may be smaller, and then I can start it to check. So if it is in DT, now let me try to run it. As you can see, it works. Because I have to check it first, and then I begin to check if it becomes smaller. Because if I didn't -1, I didn't get the right answer. I have to -1 and then begin to check if it is possible. Now let me submit it to check if it works. As you can see, it works, and it is much faster than before. So it becomes 0.2 seconds. Before it is like 1 or 2 seconds. So now the time complexity becomes O(n plus n). Thank you for watching. See you next time.